Let's say that we have a particle that is forced to live between 0, x equals 0, and x equals L, and its wave function, psi of x and t, is given by root 2 over 3, psi 1 e to the minus I e1t over h bar plus 1 over root 3 psi 3 e to the minus I e3 t over h bar, where the usual functions psi n of x are root 2 over L sine n pi x over L, and the energy levels are n squared h squared over 8m L squared, and just for completeness, the particle can be between x equals 0 and x equals L. So let's find the probability that the particle will be found between x equals 0 and x equals L. So what's the probability that it's found on the left-hand side of the 1D prism? So the probability of finding it between 0 and L over 2 is psi modulo squared in the x, but from 0 to L over 2. So if we think of this through the actual calculation, then we have to do psi star. Psi star turns this into positive, this into positive. And then we have to do times psi, which is this. So we would end up with a 2/3 integral 0 to L over 2 of psi 1 of x squared in dx plus a 1/3 integral 0 to L over 2 of psi 3 squared in dx plus 2 terms that involve non-zero time-dependent terms. So I'll just leave that blank. We'll go into that in more detail when the term actually survives, but it's not obvious at this point that it disappears. We want to avoid doing this calculation because it's easier to argue from the symmetry of these functions what the result must be. So let's plot psi 1 of x. Psi 1 of x, if this is L, then psi 1 of x looks like this. And psi 3 of x instead looks like at L over 2, we are here. And so we do something like this. So notice that these two functions are symmetric about L over 2. In other words, they just repeat themselves on the other side of L over 2. It's sort of the mirror image of each other. I can just fold the sheet over about L over 2 and get and complete the function. So these are even functions. And so it's impossible for even functions which don't lead to a preference, right? So psi 1 squared is the function that would give us the probability density, and that probability density doesn't prefer one side of the well versus the other. And the same is true here. Psi 3 squared turns this thing into a positive quantity, but it gives you the same probability density on the same probability on between 0 and L over 2 and L over 2 and L. And so neither of these two functions can at any time lead to a preference in the side on which the particle is found. So the time-dependent part has to go to 0, and it's not obvious mathematically that it does. We would be integrating psi 1 and psi 3. Of course, those are orthonormal functions, but we're not integrating from 0 to L, but from 0 to L over 2, so it's not immediately obvious that these two extra terms, the cross terms, go to 0. By symmetry, we can argue that these integrals give us 1/2, but overall we have to get 0.5 given the symmetry argument. So the calculation really reduces to 2/3 times this will give us 1/2, and this will give us 1/2 as well. And of course, overall, that gives us 1/2 or 0.5. And that's the probability of finding the particle on either side of L over 2.